Hi everyone, it's Coach Fred here, and today I'm going to be doing a review of ratios as we move into algebraic ratios and how to use algebraic ratios and with complementary and supplementary angles for geometry. But let's review. So according to the U.S. Census, there are approximately 32 people for every 10 families. This information could be expressed as a ratio. What would the ratio be? Well, hopefully you're saying you know that you could write it as 32 to 10. A ratio is really just a comparison of two or more amounts. And ratios can be expressed in two ways. You could have a part-to-part relationship or a part-to-whole. And here's what I mean. Let's pretend that we have a room of 5 animals. You have 3 cats and 5 dogs. I could say that the ratio of cats to dogs would be 3 to 5. That would be a part-to-part relationship because I have 3 cats and 5 dogs. But I could also say that I have 3 cats to 8 animals. That would be a part-to-whole relationship. Or I could do 5 to 8, which would be dogs to all the animals in the room. So those are ways I can compare numbers. We can write ratios different ways. We could say 14 to 70. We could write it, the ratio of 14 to 70. I could write it as a fraction, 14 to 70, or I could write it with a colon, 14 to 70. Same thing with x and y. I could say x to y, I could say x over y, or I could say x colon y, okay? Now, one thing that's really important is when we're writing ratios, we want to make sure that they're in the same unit. Ratios must be in the same unit. And we're going to talk about that in a second because I don't want you to confuse it with a rate, okay? So a poster is 1 meter long and 3 meters wide. Find the ratio of the length to the width. It's written as length to width, so it has to be, the ratio has to be in that order. So the length is always the longer side, and I wrote wide, so I apologize for that. 1 by 3, we would really say 3 by 1 because length to width, and length is always the longer side. So 3 to 1, or 3 to 1, or 3 to 1. Now, I want you to be really careful, too, with the colon versus an equal. For example, if I said to you 5x to 3y, and I asked you what's the ratio of x to y, I would want you to be really careful because it's not 5 to 3. It's actually 3 to 5. Mathematically, ratios are comparing. So it's saying for every 5x, I have 3y. Well, let's think about how we would simplify this. If I had 5x equaled 3y, sorry, I wanted this to be equal. 5x equals 3y, then it would be 3 to 5. The ratio would be 3 to 5. So if I wanted to get it in the form x over y, which would be x to y, let's see, I would divide by y, right? And I'd get 5x over y equals 3. Well, to get the 5, get rid of the 5 so it's in the ratio of x to y, I'd have to multiply both sides by a fifth. And so x to y would be equal to 3 to 5. So the ratio of x to y is 3 to 5. Again, I want you to be really careful when you see it like this, not to assume that it will be the ratio of 5 to 3 if there's an equals. All right, quickly I want to talk about the difference between ratio versus a rate. So both ratios and rates are a comparison of two numbers. A rate is really just a type of ratio, but the difference is that a rate is a comparison of two numbers with different units, whereas a ratio compares two numbers with the same unit. So we want to make sure that we understand the difference between those two things. So if I think of a ratio as simply the quotient of two numbers, while the rate is the ratio of two measurements that have different units, like miles an hour or dollars and ounces, it'll be helpful for you to see that. A rate is usually expressed in per unit form where the denominator is 1. So it might be miles, an hour. And I would write 50 miles per 1 hour. So 50 to 1. Okay? That's the difference between a ratio and a rate. But we're going to be working with ratios. So let's look at some algebraic ratios. Algebraic ratios you learn to simplify using the laws of exponents. But there are a few little nuances that can happen that can get tricky. So let's look at this first one. So I can simplify the 3 and the 9. 3 goes into itself once and 3 goes into 9 3 times. And the A's, I have A goes into A 1 time and A goes into itself 1 time. So those A's actually simplify to the number 1. So this would simplify to 1 over 3b. So that is an algebraic ratio. Let's try the next one. 2cd over 5c squared. The only thing I can simplify is the c's. Now remember last week we were talking about bring the smaller exponent to the larger and subtract. So the 2d would stay on the top, 5 would remain unchanged, but the bottom would become c2 minus 1, which would be 1. Okay, let me erase that so you can see. I just wanted you to see how that worked. So 5, so it would just be c. All right, now here's where it gets tricky. Simplifying ratios, you can simplify if things are expressions. So right here, x plus 4 and x plus 4, they both are raised to the 1 power, so you can actually simplify them to 1, leaving me with 3 over a. All right, let's try a few more. 4xy squared over 6y. I'm going to simplify the 4 and the 6. So 2 goes into 4 twice, 2 goes into 6 3 times. And then the y, I'm going to bring the smaller to the larger and subtract. So that's going to give me 2xy over 3. All right, you try number 5, press pause, and come back, and I will have done it, okay? All right, so you're back. And you simplified 6 into itself once, into 12 twice. You simplified 1a with 1 in the top, so you had a all over 2bc. All right, last one. I know we would really love to be able to cancel the 3's here, but unfortunately, that would be bad algebra. Okay, you can't do that. That would be bad algebra. What you can do instead is look at the expression 3x minus 12 as like a brick wall. And the only way you'd be able to simplify anything is if you would turn it into a product, turn it into multiplication. So how could I do that? Well, I could factor the bottom. That would give me 3 times x minus 4. And now I have a 3 and an x minus 6 in the top. While the x minus 6 and the x minus 4 can't be simplified, I've made it so that I can simplify the 3's. And so leaving me with x minus 6 over x minus 4. And that's a little bit about algebraic ratios. I want you to star this one because this is a big one that's going to come up a lot, and we want to make sure that we are really careful. And actually, while I'm here, I'm going to just take one idea. If I gave you this, notice the top has addition and subtraction in it. You cannot, absolutely cannot cancel the 3 x's. No, no, no. So this couldn't be simplified, even though it looks like it would be so beautiful to simplify it. All right, guys, that's it for today. The last thing I want you to do is I just want you to remind yourself what supplementary angles and complementary angles are. Go ahead and look back in your notes a few pages ahead just so you're ready for it for tomorrow so we can put all of these ideas together. Have a great night.